Let me give you an example. Consider that you are moving in a car. Okay, one more car is overtaking you. One more car is overtaking you. If the other car has to overtake, then obviously the speed of the other car is more than your car. Okay, the speed of the other car is more than your car. Means what? While traveling, while the other car is going to overtake, what we feel that the beside the car what it is moving very slow. Okay, even though the speed of the car is more, but what we feel that the speed of the car or the car is moving very slow. Okay, so this is called relative speed. So what we feel that the speed of the other car is very slow. Means what? We are having some speed, that car is also having some speed, but that car speed is more than our speed. So difference between our speed will be some x speed, and we feel that the other car is moving at the speed of x. Let me take the example, car 1, ours is the car 1, we are moving at 50 km per hour, and next other car, the other car is 60 km per hour, the other car is 60 km per hour. The other car is overtaking our car, the other car is overtaking our car. So we are moving at 50 km per hour and the other car is moving at 60 km per hour. What we feel? We feel that we have stopped. We have stopped, and what is the difference between our speed? The difference between our speed is 10 km per hour. So we feel that we have stopped, and the car which is moving beside us, it is going to travel at 10 km per hour. It is going to travel at 10 km per hour because we feel that the car is moving very slow. The car is moving very slow. Even though the speed of the car is more than our cars, we feel that the car is moving very slow. We are going to feel like that because see here, we feel that we have stopped. We feel that we have stopped and the car is moving at the difference of our speed. Okay, so this is called relative speed. We are moving at 50 km per hour. The other car which is overtaking us, it is moving at 60 km per hour. But what we feel, 60 minus 50, 10 km per hour, we feel that the other car is overtaking our car by 10 km per hour. By 10 km per hour. So when the two bodies are moving in the same direction, we want to subtract their speed. We want to subtract their speed. In reality, our car speed doesn't change, their car speed doesn't change, but we feel like that. So feeling is different, applying in the formula or applying in the problem is different. But how the relative speed is helpful for our problems? Let us discuss. In the previous example, the relative speed when the two bodies are moving in the opposite direction. Okay, for that we took an example and we have proved how we can implement the relative speed. Okay, so let us take one more example here and let us prove how the relative speed can be implemented. See here, consider the two cars C1 and C2. The distance between the two cars is 100 meters. Car 1 is traveling at 30 meter per second and car 2 is traveling at 20 meter per second. After how much time both the cars are going to meet? Obviously both the cars has to meet because car 2 speed is less than car 1 and car 1 can overtake car 2 because the speed of the car 1 is more than car 2. If it is vice versa, the speed of the car 1 is less and speed of the car 2 is more, you are never going to meet together. Okay, but the speed of the car 1 is more than the speed of the car 2, definitely you can meet. Okay, see here, in 1 second it is going to travel 30, in 1 second it is going to travel 20. So what is 30 minus 20? That is 10. So the distance between you two people in 1 second, okay, it is going to be reduced by 10 meters. See, in the first second he traveled 30 meters, in 1 second he traveled 20 meters. The car 1 traveled 30 meters, the car 2 traveled 20 meters. So the distance between car 1 and car 2 in 1 second is decreased by 10 meters. You can see now, here 30 gone, here 20 forward. So 10 is reduced, 100 minus 10, 90. In the second also, in the second, okay, Next 1 second it is going to travel 30, in next 1 second it is going to travel 20. Again in the next second, okay, the distance between the car 1 and car 2 is to be reduced by 10 meters, 10 meters. Like that, how many times you have to do? How many times you have to do? So it's a difficult task. It is a difficult task. So now what I am doing? I am going to apply the relative concept, relative speed concept. See here, car 1, car 2, 100 meters is the difference, 100 meters is the difference. So car 1 30 meter per second, car 2 20 meter per second, car 2 20 meter per second. So now what I do, see here, both of them are moving in the same direction. I am going to give the speed of the car 2 to the car 1. Okay, see here, car 2 is moving at 20 meter per second, car 1 is moving at 30 meter per second. If I stop car 2, then the speed of the car 1 will be 10 meter per second. Then the speed of the car 1 will be 10 meter per second. See here, I am applying the relative speed concept. Now I am going to stop the car 2. If I stop the car 2, so the speed of the car 2 will be 0. Okay, then the condition has to be satisfied. Then the car 1 speed will be 30 minus 20, that is 10 meter per second. Okay, so S1 minus S2 is equal to 30 minus 20, that is equal to 10 meter per second. See here, I am stopping car 2. If I stop car 2, this speed disappears. If this speed disappears, then 30 minus 20, it is going to become 10 meter per second. So if it is 10 meter per second, then per second, how much distance it is going to travel? It is going to travel 10 meters. Then how much distance is reduced between car 1 and car 2? 90 meters. If I take this condition also, in the first second, 10 meters was reduced and the distance between car 1 and car 2 became 90. So both the conditions are same. In the initial condition, car 1 traveled 30 meters per second. So car 2 traveled 20 meters. So altogether 10 meters distance reduced between car 1 and car 2. 10 meters distance reduced between car 1 and car 2. By using the concept of relative speed, easily we can identify the distance between car 1 and car 2 is reduced by 10 meters. See how easily we can identify. That is the power of the relative speed. Okay, please use the relative speed concept and where you can save lot of time. See here, S1 minus S2 is equal to distance, that is 100 by time. So time is equal to 100 by 10, that is equal to 10 seconds. So they need 10 seconds to meet each other. So 10 seconds means, see here 10 seconds means car 1, car 2, car 1, car 2, 100 meters is the distance. Okay, car 1 30 meter per second, car 2 20 meter per second, 20 meter per second. So with the help of the relative speed, we had calculated that they take time 10 seconds to meet. So what is the distance traveled by car 1? That is 30 into 10, 300 meters. So from here they have traveled 300 meters. But from here to here it is 100 meters. Then obviously this is 200 meters. Means what? Car 2 should travel 200 meters. So do we get that data? Yes. Car 2 is equal to 20 meter per second into 10 seconds, that is 200 meters. So C 100 meters plus 200 meters. So C has traveled 300 meters to catch car 2 and C2 has traveled 200 meters. Okay, see here. In this diagram also we have identified that car 2 has traveled 200 meters. So with the help of the relative speed, you can save lot of time. Okay, so the relative speed, what it says? It says that when the two bodies are moving in the opposite direction, we have to add their speeds. So why we have to add their speeds? I have shown you. Okay, if the two bodies are moving in the same direction, then what we have to do? We have to subtract their speeds. Okay, so this is very important data. If you use this data, you can solve so many problems within the less time. Okay, so now we have learned what is the relationship between speed, time and distance. We have learned what do you mean by average speed. We have learned what type of problems we can expect from average speed. We have learned so what is the formula used to calculate the average speed. If you know the distance and time, or if you have any scope to calculate the distance and time, so what formula you have to use. If you don't have any scope to calculate distance and time, then what formula you have to use, that one also we have already discussed. So regarding the average speed, each and every topic we have discussed. Next, how about the speed and time? So what is the ratio of speed and time? So how it reacts, inversely proportional to each other. So that concept we have discussed. After that, what we have discussed? We have discussed unit conversion, meters into kilometer per hour into meter per second. So what we have to do? Kilometer per hour into meter per second into 5 by 18, from meter per second to kilometer per hour into 18 by 5. So why we have to do that? Already we have discussed in detail. In the last, the important concept we had discussed, that is relative speed. What do you mean by relative speed? So when the two bodies are going to move in the opposite directions, what we have to do? When the two bodies are going to move in the same direction, then what we have to do? Okay, when we have to add, when we have to subtract, why we have to add, why we have to subtract, in detail we have learned. Okay, so time and distance, this is the introduction, this is the basics, this is the foundation for you people. If you understand this basics properly, then you can solve any problem which may come for your clerical, PO and SO. Okay, so please learn the problems properly. Let's move on to the problems. Problem number 1. Convert 90 km per hour into meter per second. See here, we want to do the conversion from kilometer per hour to meter per second. If I want to convert from kilometer per hour to meter per second, then what I have to do? See here, very simple. Already in the introductory class, we have told how to solve. 90 into 5 by 18. So from kilometer per hour to meter per second, if you want to convert, then you have to multiply it by 5 by 18. So 18 5s are 90, 5 into 5, 25 meters per second. This can be written as 25 meters per second. Okay, so the answer is 25 meter per second. So option B is the right answer. Option B is the right answer. Very simple. Okay, so you multiply it by 5 by 18. So the answer is 25 meter per second. Okay, let's move on to the next problem. Problem number 2. Convert 30 meter per second into kilometer per hour. So what you have to do here? From meter per second to kilometer per hour, you have to convert. So from meter per second to kilometer per hour, if you want to convert, then what do you have to do? So very simple guys, 30 into 18 by 5. 13 into 18 by 5. From meter per second to kilometer per hour, then you have to multiply it by 18 by 5. From kilometer per hour to meter per second, if you want to convert, then you have to multiply it by 5 by 18. So now see here, 5 6 are 30. Next 18 6 are, how much 18 6 are? 18 5 are 90, 18 6 are 108. So 108 kilometers per hour. 108 kilometer per hour. So option D is the right answer. Option D is the right answer. 108 kilometer per hour. Very simple guys. So if you want to convert from meter per second to kilometer per hour, then you have to multiply it by 18 by 5. So 108 kilometer per hour. A car covers 300 kilometer in 15 hours. Find the speed of the car. So what do you mean by speed? Speed is equal to distance by time. So distance is 300 kilometer by time, that is 15 hours. So 15 2s are 30, 20 kilometer per hour. So 20 kilometer per hour, option A is the right answer. See, these are very simple problems. These are basic problems. Only for you people I am doing these problems, okay, so that you can understand from the scratch. Because of that reason I am solving these problems. Okay, so here speed is equal to distance travelled by time. Distance is in kilometers, time is in hours. But see the options, you want the speed in kilometer per hour. So distance in kilometers, time in hours, and you want kilometer per hour. So no conversion is required, directly you can solve. So 300 by 15, which is equal to 20 kilometers per hour. Okay, let's move on to the next problem, problem number 4. See here, a bus is running at a uniform speed of 37 kilometer per hour. What distance will be covered by bus in 8 hours? See here, they have given the speed as 37 kilometers per hour, and what they have given? Time is equal to 8 hours. Then what do you have to calculate? Distance. So you want distance in kilometers. See, speed they have given in kilometer per hour and time in 8 hours. You want the distance in kilometers. So no conversion is required. Therefore, speed is equal to distance by time. Therefore, distance is equal to speed into time. So speed is how much? 37 into 8. So how much you are going to get? 7 8s are 56, 5 carry over, 8 3s are 24 plus 5 29. So the answer is 296 kilometers. So the answer is 296 kilometers. So option C is the right answer. Very simple to calculate. Okay, let's move on to the next problem, problem number 5. Problem number 5. Ram and Shyam are moving in the directions opposite to each other. See, they are moving in opposite to each other. The speeds of both the persons are 10 km per hour and 6 km per hour respectively. Find the speed of Ram with respect to Shyam. See here, when two bodies are moving in the opposite directions, then according to the relative speed, we have to add both of their speeds. Why we have to add both of their speeds? Already in the introductory class, I have told you in detail regarding the relative speed. Okay, see here, both are moving in the opposite direction. So, find the speed of Ram with respect to Shyam, that is 10 plus 6, that is 16 km per hour. Because both the bodies are moving in the opposite direction, you have to add their speeds. So 16 km per hour, option B is the right answer. 16 km per hour, option B is the right answer.